Okay, so now, ladies and gentlemen, we are going to look at the kinetic theory of gases, starting with the assumptions of kinetic theory of gases. Remember that generally, if you have a container and inside that container, you have a molecules, and these molecules generally have gaseous molecules inside them, and these molecules, each of them is having its own mass and velocity. They have their own mass and velocity. So this is x direction, and this is z direction, and this is, of course, x direction. So assuming these are the molecules, and each of these molecules have their own mass, and they have their own velocity, and let's use u to represent velocity. And of course, remember from the basic physics, if we have p represent momentum. So therefore, now we can now say momentum is equal to mass times velocity. And of course, you have a molecules here. So these molecules, they are actually they move in random direction, and of course they collide with one another, and also the collision is perfectly elastic. So when they collide with one another, all the walls of the container, they tend to bounce back. So assuming now you have a molecules here and it follows the x direction here. So if it follows this x direction, it means that our momentum is equal to mass times velocity times ux. The ux here represents the movement of the molecules in x direction. So, but if these molecules strike the walls of the container, they bounce back. So their momentum in that case is negative. So it's going to be minus it's going to be minus mu. Therefore, it's now going to be minus mu. Since it is in x direction, so it's going to be minus mux. So therefore, at the end, if we are going to have our change in momentum, so our change in momentum, which is delta p is our change in momentum, then it's going to be equals to mux. It's going to be mux minus another mux. So therefore, at the end, of course, we are going to have this mux in bracket with negative. So minus times minus is plus. So at the end, we are going to have change in momentum. We are going to have this change in momentum is equal to minus times minus is plus. So we are going to have 2 mux square. And this is how our change in momentum is going to be. And of course, at the same time, remember that there is a law that said the rate of change of momentum is directly proportional to the force applied. So when we said rate of change of momentum, the rate of change of momentum is directly proportional to the force applied. So it means that if we set the rate of change of momentum, rates, it means t. So the rate of change of momentum, it means delta t all over t is equal to or is directly proportional to f. And remember, whenever we have proportionality, we introduce constant. So therefore, at the end, we have delta p all over t is equal to kf. It means that the constant here is f. The constant here is f. So now what do we do? It's simple. So we are now going to say, but this k is usually constant, So, and the constant is 1. So therefore, at the end, we are going to have the rate of change of momentum is equal to, because when we said is 1, so it means 1 times f is equal to f. So it means that now the rate of change of momentum, which is delta p, we can now cross multiply and get ft. So it means that our rate of change of momentum is equal to ft. So therefore, we are now going to replace in delta p in the equation where we have where we have MUX, where we have MUX, we are now going to replace it with FT. So therefore now FT is going to be 2MUX, that is this. So now from here, so therefore we can now just make F subject of the formula by dividing both sides by T. So therefore at the end we are going to have F is equal to 2MUX divided by T. So after we have this, what do you do next? Simple. Then from here we have this. But remember from our basic knowledge of physics, we have velocity is equal to distance all over time. So we are now going to set velocity, which is u. We are going to use u to represent the velocity. So we have u, and let's say ux because we are talking about x direction. So us is equal to, it's now going to be equals to distance all over time. And one thing that we should know here is very important, that these molecules, as they are moving in this direction, they cover a distance L from here to here. They cover a distance L. And after they cover this distance L, at the same time, they are also bouncing back. So as they move here, they cover a distance L, and they actually come back here, they cover also another distance. So as a result of that, we also have another distance. So therefore, at the end, we are going to have L times L both in the forward direction and in the backward direction. So at the end, we are going to have our distance is equal to L. So our distance now is equals to be 2L. So therefore, since we have our distance is equal to 2L, we are going to replace it here. We are going to replace it here in this pitch. So therefore, now what we are going to say here is that we have UX, UX is equal to 2L. So therefore now we have our distance as 2L. So we are going to replace the distance with actually 2L. So we have 2L all over T. So we have this. So therefore from here, we can easily understand that we have 2MUX all over T. So we can now make 1 over T subject of the formula. So therefore, at the end, we are now going to end up of having UX. We have UX is equal to 2L is equal to 2L is equal to 2L divided by, or we can now say 1 times all over T. Because if we now say 1 times 2L, we are going to have 2L then over T. So we now have 1 over T as a subject of the formula. And so also at the same time, from here, we can also make 1 over T subject of the formula by saying F is equal to 2 we have 2M, we have, okay, by saying that 2M UX by saying 2MUX times 1 all over T. So we now replace 1 over T here. We now replace 1 all over T here with this, because here we can just easily say that divide both sides by 2 over L, and it's easy. So therefore we now have divide both sides by 2L, and here divide both sides by 2L again. So therefore now at the end, this now will cancel this. So at the end here, we have 1 all over T is equal to UX all over TL. So we are now going to replace it with this. So therefore we now have F is equal to 2M UX times UX all over 2L. So of course here we have 2. So these 2 will now cancel this. And then we have MUX times UX. So at the end, we are now going to have something like this, which is going to be F is equal to MUX. We have UX times UX. So we have MUX squared divided by L. So this is what we are going to have after we now change this. So it's depend actually on the number of molecules. So we can use capital N to represent this capital L represent the number of molecules. So if we now use this capital N to represent a number of molecules, so it means that we can now easily see that we have F is equal to capital N MUX square then divided by L. So from there, we can assume that because from our actually first, from the box, we say that we have 3 directions, X direction, Y, and Z direction. So we can assume that all the molecules are moving in the same direction. So if we assume that all the molecules are moving in the same direction, we can just say UX or U squared is equal to UX square plus UY square plus UZ plus UZ square. Then at the end, we are going to have something like this. So if we assume that they are all moving in the same direction, so we can say that let's say they move in the same direction. So at the end, we are going to have UX square. So this one plus this, since they are all the same, so we assume that they are the same. So at the end, we are going to have 3 UX square. So therefore, we can now say UX squared is equal to 3UX square. Then we can now say divide both sides by 3, divide both sides by 3. Then at the end, we are going to have this one will cancel this, of course. So we are now going to have UX square is equal to U square all over 3. So therefore, I think it's simple. From here, from here, we can easily just actually change we can easily change it, because since we said that from here, we have F is equal to NMUX square all over L. So now our UX square is the same thing as U square over 3. So therefore now our F is equal to, we are now going to replace it here. We now have F is equal to N M. So our UX square is the same thing as U square all over 3. So we're now going to say U square divided by, already we have L. So all over 3L. So we have N is equal to MU square all over 3L. So now let's look at what happened if we have the gas pressure from the different kinetic energy. So I think it's simple when we are talking about the gas pressure from kinetic energy. So what is the gas pressure? Remember that when we are talking about pressure, P is always force all over area. So we can now make F subject of the formula by saying F is equal to PA. So it means that wherever we see F, we can replace it with pressure times area. So therefore now, remember that from our previous distance, we have F is equal to N M U square all over 3L. So we now replace the F with PA is equal to N M U square all over 3L. And then now from here, From here, we can now make P of the formula. Therefore, at the end, we are going to have P is equal to NMU square all over 3 AL. And of course, remember AL, that is area times length, is equal to volume. So we can now simply replace this with our formula. So you can just replace this in our formula. Therefore, we have P is equal to NMU square all over 3V. The V here stand for the V here stand for volume, and U here stand for velocity. So from here, we can just simply say that we can actually, from this, we can derive a lot of equation. And I think, ladies and gentlemen, I'm going to stop here. Just understand how we arrive at this. Just understand how we drive at this. Then from here, we'll be able to drive a lot of equations. Like we can drive Gauss law, we can drive Charles law, we can drive ideal gas equation, we can drive general gas equation, we can drive van der Waals force of attraction, we can drive Galussa's law of combining volume, we can also drive Dalton's law of partial pressure. So, but for this class, purposely, try to understand how we arrive at this. At the end here, we can see that we have pressure is equal to number of molecules, which is N, times mass, times velocity square of the velocity all over 3 times volume. So from here, we can manipulate, we can obtain a lot of equation, Boltzmann distribution, Maxwell equation. We can drive a lot of things, but for the purpose of this, just understand how we arrive at this. Thank you.